Welcome back everybody to another video of the UCLA Bro. Today we're going to be talking about Newman projections. And before we begin this video, I want to apologize if there's a lot of background noises. Currently recording in the backyard and it's currently raining, so if there's a lot of background noises, I apologize. But I want to make a two-part video series, or just a part 1 and a part 2, talking about Newman projections. So in our part 1, which is this video, I'm going to be showing us how to visualize Newman projections. And I want to make this video for all of you guys that might be struggling with understanding how we actually draw Newman projections and how we visualize them. And in our part 2, I'm just going to be doing mostly just practice problems, and I'm going to be showing us how to draw Newman projections relatively quickly. And I'll be giving you guys some tips to draw Newman projections. So without further ado, let's get started. This is part 1, visualizing Newman projections. Alright guys, so let's talk a little bit more about what we're going to be asked to do when we draw Newman projections. So when we're told to draw a Newman projection, we'll be giving an arrow like this one right here, and that arrow tells us to look down through that angle and draw our Newman projection. So to make things a little bit easier to understand, imagine that you're standing right behind the arrow like this, and you have a pencil on your hand like that, and you're looking down at the direction of the arrow, and you're being told to draw what you see at that angle. What you would draw will be your Newman projection. But now you might be asking yourself, well, how do I draw the Newman projection? How do I actually represent it? To do that, we must learn what wedges and dashes are. And we can see that our molecule looks a little bit strange, since we haven't seen these weird looking structures that are attached to our bromine and our fluorine. So let's start with what wedges are. We can see our bromine right here is attached to a wedge. Wedges allow us to represent atoms in 3D space that are coming towards us. So right there. And we know that wedges will look like this. On the other hand, we can see that our fluorine right here is attached to a dash, and dashes, on the other hand, represent atoms that are going away from us in a 3D space, and dashes will look like that. So I have rendered this image in the bottom right here, and we're gonna use that to better understand this concept. So Newman projections are very difficult to understand in the beginning, because we are just given this molecule right here, and we're being asked to imagine that same molecule in a 3D space like that. And we have to use our imagination to imagine that, and it can be a little bit difficult. So I want to use this molecule right here to the right to explain to you guys what you're supposed to be doing in your mind to draw your Newman projection. So this is what you'll be giving in paper, and this is what you're supposed to be imagining. So in your mind. So going back to our bond structure video, we know that our carbons would be right here, and they'll be right here on the molecule to the right, and attached to them will be the hydrogens. Okay, now we can talk a little bit more about the wedges and dashes. So we can see our bromine right here is on a wedge, so that would mean that it's coming towards us in a 3D space. And we can see right here on our molecule to the right that our bromine right here almost looks like it's coming towards us in 3D space. And on the other hand, our flooring is on a dash. So that would mean that it's going away from us in a 3D space. And we can see that on our molecule to the right, the flooring almost looks like it's going away from us in a 3D space. And the same thing would be for the flooring and the bromine on the bottom. So we can see right here our flooring is on a wedge this time. So it's going to be coming towards us in a 3D space. And we can see in the molecule to the right that our flooring almost looks like it's coming towards us in a 3D space. And on the other hand, the bromine is on a dash. So it is going to be going away from us in a 3D space. And we can see on the right, the bromine looks like it's going away from us in a 3D space. So wedges and dashes are useful since they allow us to represent atoms in a 3D space in our bond line structures or in our bond line drawings. And we're going to be using wedges and dashes right now to draw our Newman projection. Okay guys, so we now have everything that we need to know to draw our Newman projection. So I have our molecule right here to the left, and I have what we're supposed to be imagining in our mind to the right. So again, remember that in Newman projections, we are looking down at the perspective of the stick figure right here, and we're drawing basically what he's seeing, and what we draw will be our Newman projection. So let's actually start drawing our Newman projection now, since we know what wedges and dashes are. So we can see that in the perspective of our stick figure right here, if we look directly down, we will have a carbon and 3 hydrogens. So that will be a CH3. So let's write that down. To the bottom, we have a CH3. Let's continue. So we discussed before that wedges are atoms that are coming towards us in a 3D space. And we can see right here that our bromine, let me pick a better color. Our bromine right here is coming towards us in a 3D space. So for the stick figure right here, the bromine would be going towards its right side, and we can draw it like this. So the stick figure has a wedge for its right hand. So in our stick figure's perspective, the bromine will be to the right, and the opposite will be for the fluorine, since we know that our fluorine right here is on a dash, so it's going to be going away from us in a 3D space. And for our stick figure right here, in its perspective, the fluorine is going to be going towards its left side. So we can show that like this. The dash is on its left side. And I know this can be a little bit hard to visualize, but I'm just going to be drawing the Newman projection now. And in the end, I'm going to show you guys a video or a demonstration, and hopefully that helps a little bit more. So since our fluorine is on a dash, it's going away from us in a 3D space. And in the perspective of our stick figure, the fluorine appears to be on its left side. So our fluorine will be appearing to the left, like that. And we're halfway done. This right here is the Newman projection for the front carbon. And now you might be asking yourself, well, how do we draw the Newman projection for the back carbon? And something that we have to notice when we draw our Newman projections is that our front carbon right here will completely cover the back carbon, almost like an eclipse. So we can see that in the perspective of our stick figure right there. If our stick figure were to be looking directly down through this angle right here, this front carbon right here would block our back carbon. Again, almost like an eclipse. So how do we actually draw our back carbon if it's completely covered by our front carbon in a Newman projection? To do that, we have to represent our back carbon as a circle. So in Newman projections, we draw our back carbons as a circle, like this. So that will be our back carbon. And we can follow the same steps that we did to draw our front carbon now with our back carbon. So let's go look at the molecule to the right again, and let's continue our Newman projection. So we can see that our stick figure right here is now going to look down through the back carbon right here, and directly above or directly to the top is going to be another CH3 right here. So we have a carbon with 3 hydrogens. So in our back carbon, we will have a CH3 going directly to the top or directly up. Alright, we can now see again that this time our fluorine is on a wedge, and that will mean that it's coming towards us in a 3D space. And in the perspective of our stick figure this time, the fluorine appears to be on its right side since it's coming towards us. So our fluorine this time would be to the right, and the opposite would be for our bromine. Let me pick a better color. For our bromine this time, it is on a dash, so it's going away from us like that. And in our perspective of our stick figure, it is towards its left side. So in our projection right here, our bromine will be to the left. And to finish our Newman projection, we now just join our front carbon and our back carbon into one projection, which will be our Newman projection. So it will look something like this. If I could get a circle. Hold up. I don't know why it's not giving me circles. Alright, there you go. So CH3 to the top, a bromine to the left, and a fluorine to the right. And now for our front carbon, we have a CH3 to the bottom, a bromine to the right, and a fluorine to the left. This right here would be our Newman projection for that molecule. And I know it can be a little bit complicated and a little bit hard to follow along, since it can be a little bit hard to visualize in your head. So what I'm gonna do now is I'm gonna show you guys a video in which we're gonna transition from our perspective right here to the perspective of our stick figure, and hopefully that clarifies a little bit of some questions that we may have. Alright guys, so I'm gonna show you guys now a visual representation showcasing what we were just talking about right now. So right now we're in the perspective of the bond line structure, the one we were given, and we were told to imagine in our heads how it looked like in a 3D space. And we can see right now that our wedges are facing us and our dashes are going away from us like we talked. And what I'm gonna do right now is I'm gonna rotate the molecule to the perspective of our stick figure, and I want you guys to notice what happens to the front carbon and the back carbon, and specifically I want you guys to notice how the front carbon completely blocks the back carbon. So let's do that right now. So right now I'm rotating the molecule to the perspective of our stick figure. So I'm gonna show you guys basically what our stick figure was seeing. So notice how the front carbon completely blocks the back carbon. And now we have a weird looking structure that looks kind of familiar because this was basically our Newman structure that we just drew right now. Notice that for our front carbon, to the bottom was the CH3 that we talked about. To the right was the bromine that we talked about, and to the left was the fluorine. And for the back carbon, which we cannot see, which is covered by the front carbon, to the top was the CH3 that we talked about. To the right was the fluorine, which was on a wedge, and to the left was the bromine, which was on a dash that we were talking about. And this is basically what Newman projections are. They're basically just asking us to draw the perspective of the arrow. And if we remember what we were talking about, it's basically just the perspective of the stick figure. So we're basically just drawing what the stick figure sees in this perspective. And what we draw is basically the Newman projection. So let's actually compare this structure right now to the Newman projection that we just drew. Alright, so let's actually compare them now. So if we remember previously from what we talked about, our stick figure is right here, and it's looking directly towards that angle, and the molecule, which is our Newman projection. And as we talked about, for our front carbon, our bromine right here was on a wedge, so it's coming towards us in our previous perspective. But for our stick figure, it was actually on its right side, or on its right, basically on its right side, and we represented it to be basically a wedge on its right hand. And on the other hand, the fluorine was on a dash. In our previous perspective, it was going away from us. But for our stick figure, the fluorine on the dash was actually on its left side, and we represented that by drawing a dash on its left hand. And directly down to the bottom was a CH3, which we have right there. And we can see that it is very familiar or very similar to what we drew in our Newman projection. As we can see, we had a CH3 to the bottom, our bromine to the right, and our fluorine to the left. And that was very similar to this structure to the left, as we had our CH3 directly down, our bromine to the right, and our fluorine to the left. And this is basically what Newman projections are. They're basically just asking us to draw what our stick figure sees, and what we will draw will be our Newman projection right there. So let's talk about the back carbon now. So as we discussed before, the front carbon completely blocks the back carbon, but it does not mean that our back carbon is not there anymore. And we can see in this image right here, we cannot see the back carbon, but we use a circle to represent that our back carbon is there. It's just being blocked by our front carbon. And we can see that similar thing would apply to our back carbon, as directly to the top was our CH3, and to the right was our fluorine, since it was on a wedge and it was going towards us in a 3D space. And for our stick figure, it was on its right side. And on the other hand, the bromine was on a dash, so it's going away from us in a 3D space in our previous perspective. But for our stick figure, it was on its left side. And this was very similar to what we drew in our Newman projection to the right here, as we had our CH3 to the top, our fluorine to the right, and our bromine to the left. And this is very similar, since we had our CH3 to the top, our fluorine to the right, and our bromine to the left. And this is basically how we draw Newman projections, or how we visualize them in a 3D space. And I know this could be a little bit difficult to kind of comprehend, but with more practice in the future, it will become a lot easier. I just wanted to make this video or this part of the video to help you understand how it is that we draw Newman projections and how we actually visualize them. And once you understand how they are visualized, drawing them can just be a lot easier, and you'll notice that there's a lot of patterns that you can follow to draw Newman projections. So that was it, guys, for part 1 of visualizing Newman projections. Hopefully you guys learned something new, and if you guys have any questions, let me know. If there's something that you didn't find very helpful, just let me know what ways I can improve the videos, what things I can do more and what I can do less of. And yeah, hopefully you guys learned something new, and I'll catch you guys in part 2 of this Newman projection series.